we have a theorem that it's a pretty cool theorem called the remainder theorem. It says that if a polynomial is divided by x minus k, then the remainder is actually f of k. Okay. This gives us a way to evaluate a function at or a polynomial at a number. We just do synthetic division, which is a pretty quick process. So let's see that here in action. Use the remainder theorem to evaluate f of x equals 3x cubed plus 8x squared plus 5x minus 7. To evaluate it, and this should say at x equals negative 2. Let's evaluate it at negative 2. All we do is we do synthetic division. We put a negative 2 out here. That's what we're trying to evaluate at. And inside we put the coefficients of our polynomial. 3, 8, 5, and negative 7. We bring 3 down. 3 times negative 2 is negative 6. 8 plus negative 6 is 2. 2 times negative 2 is negative 4. 5 plus negative 4 is 1. 1 times negative 2 is negative 2. And negative 7 plus negative 2 is negative 9. And the remainder theorem says that the remainder is f of k. In other words, what we just found is that f of negative 2 is equal to negative 9. This is a synthetic division is quite a bit faster than actually plugging negative 2 into this and evaluating it. Okay, we could certainly do it. Okay, if you plug in, and let's go ahead and do it just for this one, just so we can see. All right, if I wanted to evaluate f of negative 2, I'd have 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. Okay. And then we'd have to go through and figure this out. So 3 times negative 2 cubed is negative 8. And negative 2 squared is 4. Okay, so that was doing our order of operations. We did our exponents first. Then we can do our multiplication. This is a negative 24 plus 32 minus 10 minus 7. And then we can simplify. Negative 24 plus 32 is 8. Minus 10 is negative 2. Minus 7 is negative 9. Okay, so we see we got the same thing, okay, which we should because that's what the remainder theorem tells us. So it's a pretty powerful theorem, and it allows us to evaluate polynomials pretty quickly using synthetic division.